Free radical polymerization. Initiation. We know that free radical contains lone unpaired electron. A lone electron is like a prospective bachelor, always looking for another lone electron to couple and get stabilized. So, you have already seen what is free radical polymerization in your organic chemistry of first year. The same thing is here. So we will just revise it. A free radical is therefore highly reactive and can attack any molecule which either has a lone electron or is prepared to part with one of its electron. This is what happens in the process of initiation. The free radical R star attacks the double bond in the monomer molecule, resulting in the following chemical chain. Suppose this is a monomer CH2CHX. If X is replaced by Cl, this will be a vinyl chloride monomer. So R star attacks here and then the chain is initiated. Okay, it attacks the double bond gets converted into single bond, and we get the R single bond CH2 single bond CHX, and the radical side form R is now shifted to CH. The process is explained as follows. In a double bond formed between two carbon atoms, one pair of electron exists as sigma. Okay, if there is a double bond between here two carbons, then one pair is sigma. One pair of electron exists as sigma, while the other pair occupying certain orbitals in the molecule not close to the nucleus exists as pi electrons. If we denote the sigma electron pair by a dash and the pi electron pair by two dots, the double bond between two carbon atoms can be represented as like this. Now I am representing the pi electron pair as two dots and sigma 1 as a dash instead of the usual representation. The representation of the pi electron pair by two dots by itself is not really correct, since the electron exists as a diffuse cloud and are also constantly under spin. But since it is difficult to show an electron diffuse cloud in the formula, the notation using a pair of two dots has become an accepted practice. So you cannot show a diffuse electron cloud, right? So you can denote it by two dots. The pi electrons are not very close to the nucleus and protrude a little away from the axis of the molecule. They are therefore susceptible to attack by the reactive species. When free radicals are produced by homolytic decomposition of the initiator, what happens is that the free radical interferes with one of the pi electrons and form a normal pair of electrons at sigma level. So see now what is happening. Since they are far away from the nucleus, so they are susceptible to the attack. They are therefore susceptible to attack by other reactive species. When free radicals are produced by the homolytic decomposition of the initiator like benzoyl peroxide, what happens is that the free radical interferes with one of the pi electron pair and forms a normal pair of electrons at sigma level, and the other electron of the erstwhile pi pair is transferred to the other end of the molecule. So like I said, this radical side is transferred here. The jump of the dot in the direction of the arrow should be noted. This jump of the dot in the direction of the arrow. So this electron went here and formed a sigma bond, and this went at the other side. It is as if the two pi electrons of the monomer molecule divorce each other. So they both go in different directions. So they divorce each other. And one of the separated partners couples with the lone electron present in the free radical to form a sigma bond, this sigma bond. Okay. Now the monomer unit is linked to free radical unit through sigma bond, forming a single molecule. The other electron of the original pi electron pair, now deprived of the partner, becomes unpaired. That is to say, the free radical site is now shifted from the initiator fragment to the monomer unit. This process of the electron pair coming down from its pi energy level to sigma level is associated with the release of energy of some 20 kilocalories, as pi electrons are at a higher energy level than sigma electrons. So now it came from a pi to a sigma level. Okay, so pi electrons are at a higher energy level than sigma ones. Okay, so there is a release of energy, 20 kilocalories. Hence, the free radical attack on the monomer initiating polymerization is an exothermic process. Energy release means exothermic, whereas free radical formation by initiator decomposition is an endothermic process. That means it takes the energy. The whole sequence in which one free radical attacks a monomer molecule adds the monomer molecule to itself, and while so adding, simultaneously transfers the free radical site from itself to the monomer unit is termed the initiation step. So I hope you're clear with the initiation step. Now let's see the propagation. After initiation comes propagation. In the propagation step, the radical site at the first monomer unit attacks the double bond of the fresh monomer molecule. This results in the linking up of the second monomer unit to the first and the transfer of the radical site from the first monomer unit to the second by the unpaired electron transfer process. So here, now this you got in the initiation step. Okay, here this you got. Now another fresh monomer species is here. This gets attached to this and another, the radical side is shifted here. So it should be noted that this chain still contains a radical site indicated by dot, and its n carbon atom can therefore attack yet another monomer molecule and thus take it on with simultaneous transfer of the radical site to the new monomer unit added. So this you get another fresh monomeric species. Now it is getting attached and the chain is propagating and the radical site is shifted to the last molecule. This process involving a continuing attack on fresh monomer molecule, which in turn keeps successively adding to the growing chain one after another, is termed propagation. The propagation lasts till the chain growth is stopped by the free radical site being killed by some impurities or by a shear termination process, or till there is no further monomer left for attack. The structure of the growing chain can be represented as like this, where n denotes the number of monomer units added up in the chain growth, and the wavy line indicates the polymer chain made of n number of monomer units. The mode of addition of the incoming monomer to the growing chain can be of head to tail to tail, head to head, tail to head type. We, if we call the CH2 and the CHX part of a monomeric unit as its head and tail respectively. So CH2 head and CHX as tail. The four modes of addition can be represented as follows. So CH2 is the head, CHX is the tail. So here in this case, CHX is getting added to CH2. So I can say it as head to tail. Okay, because I am adding this CH2 which is the head to CHX. Therefore, head to tail. Now in this case I am adding this tail to tail. In this case I am adding head to head, CH to CH. In this case I am adding tail to head, like that. So you have to write first the incoming monomer species, what it is, like it is head, so you have to first write head and then to tail of the growing polymer chain. Okay. As explained earlier, each time a new monomer unit is added to the growing chain, the pi electron pair cascades down to the sigma level. Whenever this happens, there is an energy release of about 20 kilocalories, and hence the process of chain propagation is brought about without adding any external energy to the system. In other words, a very small amount of energy is supplied to decompose the initiator so as to form its free radical fragments, and the polymer chain starts growing with large amounts of energy release. So why there is no external energy provided during propagation? Because there is a exothermic reaction, there is the energy release, and because of which it just goes on. Termination. After propagation comes termination. As you would guess, any further addition of monomer units to the growing chain is hereafter stopped, and the growth of the polymer chain is arrested. Since the decomposition of the initiator produces many free radicals at the same time, each one of them can initiate and propagate the chain growth simultaneously. So many free radicals are produced during the decomposition of the initiator, and then they can also start the chain growth, and hence at any given time there may be quite a few growing chain present in the system. Depending on factors such as temperature, time, and monomer and initiator concentration, there exists a statistical probability of the two growing chains coming close to and colliding with each other. When such collision takes place, the following two reactions may occur, resulting in the arrest of the chain growth. So, two growing chains coming in contact, then tail to tail addition, and the radical side is stabilized by the joining of the two growing chains. So, this is termination by coupling. But another cases where one gets stabilized by giving one hydrogen, this hydrogen to this growing chain, and getting a double bond, and here getting a CH2, and that's how they are stabilized. This is another case. In the first case, the two growing chain unite by coupling of the lone electron present in each chain to form an electron pair, and thus nullifying their reactiveness. Since this process involves coupling of the two lone electrons, this kind of termination is known as termination by coupling. In the second case, one edge from one growing chain is abstracted by other growing chain and is utilized by the lone electron for getting stabilized, while the chain which had donated the edge gets stabilized by the formation of a double bond, like I said earlier. In this case, the termination process results in the formation of two polymer molecules of shorter chain length as against a single molecule of a longer chain length obtained by the first method. This type of termination is called termination by disproportion. Number one is termination by coupling, number two is termination by disproportion. From the foregoing termination reaction, it may be noted that the product molecules formed did not contain any free radical site, hence cannot grow any further. The process of termination thus results in the deactivation of growing chain. The deactivated chain, in fact, forms the polymer. In order to contrast it with an active growing chain, the polymer molecule formed can be referred to as a dead polymer chain. We know that a polymer molecule is made up of several repeated units. From the termination reactions given above, it may also be noted that in addition to several repeating units, the polymer molecule contains certain other groups as well, like R and CH2 double bond CHX. In this case, at the two chain ends, these groups are called the end groups. So this is all regarding free radical polymerization. I hope you understand. Read it again and you'll get it.